Hello. So we're going to discuss case 2 of the centroid. So here we have a region that is bounded above by the function y equals f of x, below by y equals g of x, to the left by the line x equals, the vertical line x equals a, to the right by another vertical line x equals b. And the question is to find this centroid, x sub c comma y sub c. So so here for this case number 2, the formula is that you use x sub c equals 1 over a times the integral from a to b of x times quantity f of x minus g of x. So f of x is the top function, and then g of x is the one below, the bottom one. So that's the difference between case 1 and case 2 here. And for y sub c, or y bar, we have 1 over a times the integral from a to b of a half times, then you square each function, and then you take the difference. So f of x squared minus g of x squared. That's what you're going to integrate. Okay, that's just a way to rewrite it if you bring a half outside. Now here, on this case, the area of the region is basically the integral from a to b of f of x minus g of x. So let's look at an example. We are asked to find the centroid of the region bounded by the curve y equals the square root of x, which is this, and then y equals x, which is the straight line here. So we're looking at this region. Okay, we want to find the centroid. So we know f of x is a square root of x. That's the function that is above, and then g of x is the one below, which is x. So we need to integrate over an interval. So we know the two curves are meeting at 0, the origin. So what is then this point here? So to find this point, since it's not given to us, it's a point of intersection. So what it means, we're going to set the two functions to be equal and then solve for x. So we're going to set the square root of x equals x. We square both sides. We get x equals x squared. We factor out x, and then solve this equation. We get x equals 0 and x equals 1. So basically here, at this point here, the x value is 1. So therefore the y value is 1 too. So this point is 1 comma 1. This is 0 comma 0. So we find a limit of integration. So a is 0, b is 1. So to find, the first step is to find the area of the region, which we know we're going to take the integrate f of x minus g of x. So f of x is square root of x, g of x is x. So we're going to integrate these two terms. First we change x to square root of x to x raised to a half, and then we find its antiderivative, which is x raised to 3 halves divided by 3 halves. When you divide by a fraction, you flip and multiply, get 2/3. Here x squared, x give us x squared over 2, and then we evaluate this two expression as 0 and 1. First we plug in 1 for x and then 0, and then we end up with 1 over 6 as the area. So now we go to the next step, is finding the x coordinate of the center of mass, okay, or the centroid. So we have, this is the formula. So we know f of x is square root of x, g of x is x. So we're going to distribute x, but before we do that, we'll have to change the square root of x to x raised to a half. So then we take x times x raised to 1 half is x to the 3 halves. Then x times x give us x squared. And since a is 1 over 6, if you put the 1 over 6 in the denominator, then you have 1 divided by 1 over 6, which gives you 6. So again, from here we find the antiderivative of each term, and then we plug in 1 for x and then a 0 for x. So that gives us a 2/5 as x sub c. And then last we go to the y coordinate of the centroid. This is the formula. We put this down. We know f of x is the square root of x, and then g of x is x. So here we're going to get x, and there we're going to get x squared. So then we, again, when we put 1/6 here, we can simplify 2, we get 1/3. When you flip and multiply, you get 3. So you get 3 here. You find the antiderivative of x, which is x squared over 2. The antiderivative of x squared is x cubed over 3. So you plug in, you evaluate, and 1 is 0. So plug in 1 for x and then 0 for x. And then you end up with a half. So for this problem, the centroid is located at the point 2/5, 1/2. Thank you.